Okay, so we're just going to do these couple of examples. So examples, round 4.563 rounded to 2 decimal places. 4.563 rounded to 2 decimal places. So we got 4.56. Okay, great. So we want to round it to the second decimal place. So we're rounding it to this. But in order to round it to the second decimal place, we have to look at the next one along. We've got to look at the third decimal place. So we look at the next one, which is 3. 3 is less than 5, which means you're going to round down if you like. So this equals 4.56. The 6 stays the same because 3 is less than 5. Right? And you always have to specify 2 decimal places. This is really important, specifying 2 decimal places. That's fine. All right, so this one, you look at the second decimal place to start with. And so, well, 6.8 is to 2 decimal places. Okay? So again, just touching on this, a huge amount of time. Well, I've got something else to do. Yeah. No, don't worry about that. I'm about to go down. I just think I'll come back to it after. Leave some space. Okay, the other thing that we're talking about. I'll put it up. Now, hands up if you've heard the term significant figures before. Value rounded by significant figures. Alright, so this is important. If you have not heard this, this is decimal rounding you've heard about. Significant figures is another. So I just want you to listen, and then you have time to round. So basically what significant figures are, it's a way of identifying and estimating or making things a useful number. Okay, so a good example is, at this school we say we have 1,300 students. Now, the exact number is about 1,280 something. We're not really interested in the exact number. We're just interested that, okay, for the nearest 100, it's about 1,300 students coming here. Because that gives us an idea of the size of the school. All that sort of stuff. Yeah, that's right. That's not really it. That's right. Let's say 8,000 is fine. Okay? So, it's a way of identifying, guys, listen carefully. It's a way of identifying what digits, what values, place values are important, and what are, for certain instances, not so important. Okay? And it's about accuracy. So we're going to do some examples, but basically, to count significant figures, you start at the left of the number, start the left-hand side, and you find the first non-zero numeral. And so non-zero, as long as it's non-zero. And this counts more when it's a decimal, 0.00. You find the first non-zero digit, that's significant figure number 1. That's your first significant figure. Every digit after that, whether it's, if it's non-zero especially, but if it's 0 between non-zero digits, is counted as significant. So you have 1 is the first one, and then you just count along. That's your second significant figure, third significant figure, fourth, etc., etc. Alright? Go on to so it's better when we look at some examples. So then, Now, zeros between non-zero digits are counted as significant because they hold a place. It's an important piece of information. With whole numbers, after all the numbers are finished, and you only have zeros left. For example, you might have 3,450,000. All those zeros at the end are not significant. For decimals, the zeros at the end of decimals are significant because they indicate greater accuracy. So, I am going to show you a couple of examples. I'll come back to this to write down. I really want you to just listen to this and see how we go. Right, first one, 5,670. The question is, how many significant figures are these numbers written to? Alright, so this is important. We say, well, I'm going to rewrite it here. 5670. We start at the left. The first number is, the first digit is 5. That's significant figure number 1. Right? Then we have the 6. So that's counted. So that's significant figure number 2. 7 is significant figure number 3. Now, according to what we said about whole numbers, zeros at the end to the right of all the others are not counted as significant. Zeros, because they're just holding the place. They don't show that it's any more accurate. So this one is not actually a significant figure because it's just at the end of the number, the right-hand side, filling in the place value. So this is actually written to 3 significant figures. Yes. That's right. 10, the number 10 is written to 1 significant figure. The number 10 is written to 1 significant figure. Yes. Oh, 0, 0 at the end, then neither of them are significant. Okay? So let's have a look at this one. 120,000. 120,340. Alright? So I'll rewrite it again. 1, 2, 0, 3, 4, 0. Okay, we start at the left. Find the first non-zero digit. That's the 1, so that's a significant figure 1. Okay, that's counted because 2. This one is a 0, but because it's between 2 other non-zero digits, it's actually counted as significant. Okay, it tells you something about the number. So 3, 4, this one's 5, and then this last 0 is to the right of everything else. So it's not counted. It's only holding a place. It's not telling us anything about how accurate this number is. So this is not significant. So this one is written to 5 significant figures. Questions? Any questions about this? So the idea again, I'll say it again. You start at the left and you find the first number that's not 0. Every number after that that's not 0 is counted. Zeros that are between 2 non-zero numbers are counted as well. Once all the numbers that aren't 0 are finished and there's zeros left over in a whole number, those are not counted as significant. Okay? Yes. Again, it helps you to round things that aren't necessarily decimal. Okay, so you can round like 1,457,000 round into 2 significant figures. And I'll show you some examples. Yes, Josh. Yes. No, the zeros at the start are not significant for decimals. Right, so 0 point, you have to find from the left the first non-zero. And the first non-zero value is 5. So this is actually written to 2 significant figures. Yeah, that's true, but they're not significant because these numbers are only holding a place. It doesn't tell you actually about what we're interested in these numbers down here. See, these zeros are just telling us that it's becoming smaller and smaller decimal. It's not actually anything about the value of the cell. number 4, we can go through. Sorry, Brock, your question. 6,008? Those are significant because they're between non-zero values. So that would be 4 significant. Right? As long as you could have 6 zeros in between 2 non-zero values, and all of those are counted as significant. 0.060780. These zeros are not significant. So this is 1, 2, 3, 4, and zeros at the end of decimals are counted as significant. Alright? 5. So this one is 5 significant figures. What I'm going to get you to do is write down these examples, write the notes here, and then write the examples, and we're going to do the first part of this exercise, so you can follow it through. We can come back to this. If you want to start the lesson tomorrow with this, and go through. Yes, sure.
We go to the house for
Yeah, what else to do? Okay, so write this stuff down. Try to understand what I'm saying. It's a little bit funny when you first introduce it, but its uses are, they're quite useful because you can round things easily and express it in certain ways without having to have decimal places. It's a very big number you can write in just 2 significant figures. I'll go into the class. I think maybe you can do like computer stuff.